Hello and welcome to this video. In this video, let us see how to insert an element into a binary search tree. So in order to insert an element into a binary search tree, it must follow all the conditions that needed to be true for the tree to be a binary search tree. So let us read all those conditions. So the first condition is the parent should have only two children. Then left subtree of a node contains value lesser than the parent. Then right subtree of the node contains greater value than parent. As we can see here, the left subtree has lesser value than parent and right subtree has the greater value than parent. And left and right subtree must also be a binary search tree. So left tree must also be a binary search tree. That means it also follows the same conditions. That is, the left value should be lesser and the right value should be greater than the parent value. So let us see how to implement this. So here we have given an example to create a binary search tree. So from this number we have to build binary search tree which follows all these conditions. So here is the piece of code that we will follow while creating a binary search tree. Now let us understand this code. So the first statement is we are defining the insert function and we are taking a root and a key that we want to add. So we are taking a key that we want to add, but instead of key we have used data while creating our binary search tree. So this is one and the same. So we are taking root and the key. Then we are checking if the root is none, that is there is no tree created. So if the root is none, then we are creating the node for root and we are returning the root as the first node. Then after that, our second condition was the left subtree should contain lesser value than the parent. That means if we get the lesser value than parent, then we will insert that node to the left side of tree. That is, we are traversing to root dot left, which means the left side of the tree. And the third condition was the right subtree value should be greater than the parent, which means if this condition is not true, which means the value is greater than the parent, then we will go to the else condition and we will insert that value to the right side of the tree. So this is how this program will run. Now let us solve this example. First we have 5, so we have inserted 5, so our key is 5. Now we will check if there is a root. So there is no tree up till now, so the root is none. So what we will return? We will return a node of key. So we will create this 5 as a node and we will return this. So we have 5 here and it is a root. So by following this first if statement, we have created a root as 5. Now we will get 3 and pass this to the condition. Then we will see if root is none. So root is not none because we already have 5 as a root. So we will check if the key is lesser than root, which means 3 is lesser than root. Then this condition is true. Then we will insert this. So we will pass this key to the left side of the root. So let us create that. So I will draw an arrow to the left and here we have 3. Now we will go to 7. In 7 we will check if the key is less than root dot key. So we are now here at the root. So it is not lesser. So we will go to right and insert that. So we will go here and insert here 7. Then again we will start with 8. Then we have 8. If 8 is less than the key, it is not, we will go with the else condition, that is we have to insert it to right. So we will pass here root dot right, but there is a root dot right present. So this insert statement will again call with the same key, which is 8. Then it will go to again right of that. So it will go again to the right, and as there is no right here, so it will add 8 at this position. Now we will get 2 as a key. Now this condition is true, that is key is less than root, that is 5. Then we will go to 3 and we will again check if key is less than root, that is again true. Then we will go to again left because this condition is again true. Then after going to again left, we will see if there is any element. So there is no element, so we will add here the 2. Now we will have 4. So for the 4, so now we have 4 as the key. So if we will check this condition, if root is none, so root is not none. So then we will check if key is less than root dot key, that is key is less than 5. So the answer is yes. So we will go to 3 and we will check if the key is less than the root, which means 3. If it is less, so the 4 is not lesser than 3. So we will go to else condition and we will go to the right, because here it is root dot right. So 3 dot right will be here. So there is no other element to check. So we will add 4 here. So here it should be 6 as it is already added previously. So we are at the 6. We will check if the root is none. So we have root as 5, so it is not none. Then we will go to second condition if key is less than root dot key, that is whether 6 is less than 5. So this condition is false. So we will go to right, that is we are on the 7. Then again we will check if it is none. So it is not none. So we will go to second condition if it is less than 7. So this condition is true. So when this condition is true, we go to left. So we will go here and we will check if it is none. So it is not none. Then we will add 6 over here. So we have added all the element that we have given. So let us check this with the original tree we have. So this is our original tree and you can compare this with the tree that we have created, that we have 5 on the top, then 3 7, 2 4, and then 6 8 6 8. So this tree matches with the tree that we have created. So we have got the right solution. So let us implement this code in our Python. So let us copy this. I'm at the PST file. Let us paste our insert statement over here. So instead of inserting the nodes manually, so let us try that using a function. So here we have to insert a 3. So I will write insert and I have to pass the root and I have to pass the 3. Then similarly 7, 2, 4, 6 and 8 we have to add. Let us do that. So we have inserted all the nodes. Now let us say we get the same thing for the in order traversal as we previously was getting. So let us comment the remaining code out and let us try and run this code. So instead of the key, we have used data over here. So I will change key to data. So data and run the code. So we have got 2, 3, 4, 5, 6, 7, and 8. So this is the same solution as we previously was getting. So this is how you can insert the node into a binary search tree. I hope you have understood how to insert an element into a binary search tree. So thanks for watching this video, and I will see you in the next one.